Hello, audio check, audio check. No, my voice is audible. Hello, audio check, audio check. My voice is audible. We're gonna do audio check quickly. I think now it should be good. 1 second. Yep, no background noise should be there. Okay, so let's just check once again. Hello, hello. Voice check, voice check. Well, okay, cool, cool, cool. Okay, so the first problem that I'm going to take a look at it. So this is going to be first binary search, right? Uh, search. Just solved a very easy problem where you just have to do a binary search. So basic idea of binary search is that you can kind of rule out the problems, right? You can decrease the space. So that was first thing, and so basically, um, you know. I'm gonna use blue color. So basically binary search works in this manner. So if given array is sorted right, given in a sorted array, if you have to search for something, let's say 3, so you can kind of break it and then see whether this element, the element that you are currently at, if it is greater than you know that your element is on the left side, right? So once you do that, so once you kind of do this right, what basically happens here is uh, that you have kind of reduced this space. So basically, if you have kind of, let's say, n element, you have decreased it to n by 2, then n by 4 like this, right? So this becomes logarithmic of n, right? So that's the concept behind it. Now, let's say search matrix, right? Now, search matrix, what it says is that you are given a 5, 7, 10, 11, 16, 20, 23, 30, 34, 60. So it is sorted both ways, right? So the idea is that you want to remove the rows or you want to remove the columns, right? So if you look at this, if your element is greater than this, so basically this whole row goes away. And if it is less than this, so this goes away because these are greater, right? So that is the idea behind this problem. So in n is equal to matrix dot length and m is equal to matrix dot 0 dot length. So I will be 0 and j will be a number of columns minus 1 while I is less than n and j is greater than equal to 0. So if your matrix of I comma j is equal to target, that means you are good. You have found that. So we need to return true. Otherwise, if matrix of I comma j is greater than target, the element that you currently have is greater. So basically all the rows are greater, right? So then you can just get rid of the last column. So j is equal to j minus 1 else I plus plus. Because this is less, so you need to move to the next because all the other elements are anyway less. So return false. Basic easy problem. We'll take a 5 minutes break. So we are going to resume. Okay, cool. Uh, so there are different ways of doing by. So there are different ways of doing binary search. So one way could be binary search on the answer. So the given problem states that Coco loves to eat banana. There are n piles of banana. First thing that will say this, okay, there are n piles of banana, right? That is the first thing that we can see, right? Now they want to see the cards will have gone and will come back in a charge. So we have a charge, right? Now H is 8. It is given 8. And Coco can eat one banana per hour, I think. Can decide her bananas per hour eating speed of K, right? Each hour she chooses some pile, eats K banana. Okay, each hour she can eat K bananas, right? Now, one thing that if let's say K is 1, then it would need 3 hours to eat this, 6 hours to eat this, 7 hours to eat this, and 11 hours to eat this, right? But it will be only 1, so it will need total 3 plus 6, 7, and 11. If the pile has less than K bananas, she eats all of them and will not eat any more during this hour, right? So the K is there. Like if let's say its speed is let's say 10, so it will spend 1 hour eating this 10, 1 hour eating these 10 bananas, right? So eat all bananas, minimum K, right? So we have to minimize the speed of the banana. So for example, 3, 6, 7, 11. If I hours are 8, right? So one way could be to eat all of these in the minimum hours, and they have said that the H is greater than pi, right? Because we would need that to be true. Otherwise, you could never eat those bananas in that time frame, right? Because let's say you started eating this pile in 1 hour, and let's say gift card comes back in 3 hours. Even if you say that okay, I can eat 11, so one you will take here, one you will take one here, you will not have the another hour to eat this thing, right? Okay, so let me do just one thing here. Let me just once. Let me start a new link. Usually this is like binary search on answer, right? So K I have to find. Okay, I have to find right now. So now what could be minimum value of K, right? H is it. K ranges from what could be minimum that you should at least you could say that okay, I'll eat one banana per hour. Then you are going to take number of bananas are there, number of hours you are going to take, right? For maximum you can say that okay, I'm going to Maximum value for k will be whatever is the maximum of this, those many bananas you do, because then your h will be whatever is the length, right? Now you want to decrease your k such that you can take more also, right? Increase your k basically. So now there is a range, right? Basically this k has a range now. So that is where, how can I do this, right? Uh, so let's say k low is 1. By 1, what I mean that you can only eat one banana per hour, right? So then you will take number of bananas, take 3, 6, right? Number of bananas that you can eat in every of the iteration. But I is equal to, for now we'll keep it 1, but it will change. For int pile in piles, method makes of high comma pile. So you're saying that maximum banana that you can eat per hour is that pile, so that it will be like k will be maximized, right? Now while low is less than equal to high, right? This will never fit. This will hardly fit in H. So now int mid is equal to high minus low. Check if it is possible to eat all bananas with mid speed, right? So uh, if check speed, we need piles and H number of hours you have, and then you have speed, right? If this is true, then sir, your answer becomes then you want to kind of try the lower one also, right? Else you need to increase your speed. So by default, I can say int answer is equal to high, low is equal to mid plus one. Now this is the important part, public boolean check int piles, int hours, and int speed, right? Now int eaten is equal to 0. Over and time taken. I is equal to 0, I less than, I just need piles, right? And piles. Now to eat this whole pile, right? How many hours, how many hours you need to eat this whole pile? So that will be uh, how much divided by pile, right? How many bananas it has. So if let's say it has 5 bananas, right? And your speed is 2. So you need 5 by 2, that is 2, but you need 5 plus 4 by 2. No, the number that you are dividing it by, right? So 5 plus 1 by 2. If let's say it is 3, then you need 5 plus 2, right? So that it is always there. So int taken is equal to pile plus speed minus 1 by speed. Right? That many hours you need. Now if taken is greater than hours, then you return false, return true, return answer. Because in pile you can only eat those many bananas, right? Mid. Speed is mid. So we will take Okay, guys, so we'll solve these problems again. Okay, so the idea here is right. The concept. Okay, guys, so we'll solve these problems. So the idea here is right. The concept. Mm, so find the minimum rotated sorted array, right? Minimum in a rotated sorted array. So basically, what happened basically is that you had an array, right? I'll not use this color. Let's. There are no more colors. Let's share this one. So it was sorted, but someone came and then rotated it. So it became something like this now, right? Now what generally happens in here is there is an element such that its left is also greater and right is also greater like this. This point is there in the array, or you can think of it like this. Not not actually. So 5 is also it's like this, right? So it is increasing here and again it is increasing. So array is like this. So this is the point, right? So we'll call it pivot. If somehow we can find this pivot, right? So in this, the pivot will be this thing, 1. If somehow we can find this, then in the left I can do binary search, on the right I can do binary search and see, right? So still that will be log of n. So that is now how to find the pivot, right? Can we find the pivot using the same? So one way of finding the pivot is, right? So again you do the binary search and then let's say you reached here, mid, right? Now here you can check if this element is greater than the first element, right? So that means that it is in sorted manner, right? If that is the case, right, then you know that your pivot is on the right side, right? Now, if let's say it is not, right, then you know that your pivot is on the left side, right? So let's say it is something like, for example, 4, 5, 6, let's say 7 is there. So it is rotated here, right? So you know that the pivot is on the left side. That is the thing, right? Now, that is one case, right? To move, how to move to left and right. But also we need to check one thing. What if the element is, let's say you are at this element and it is, then you know already know that that is the pivot. So that is another thing, right? Movement, you can check uh, if it is the pivot that you can check. Now there could be case that it is on the left side. It is the zeroth element or the last element, right? What you will do in that case? In that case, what we can do is, if this is the smallest, right? If this is the element, right? And if its next is greater, or let's. So then this means this is the pivot, right? Same you can do with the last. Otherwise, you'll have to move to the right. Same way, if this is 6 and 2, if this is greater than this is the pivot, you move to the left. So two things basically. Check if it's the pivot, otherwise move, right? So that's what we will do. Public int find pivot and low is equal to 0, nums dot length -1. If not rotated, it will just say that is the pivot and you do left. Now, now if mid is equal to 0, that's one case. Else if mid is equal to, that's another case. Or if it is in between, right? Now if it is this, right? And there could be array that the element is only one length, right? That I'll separately. So basically you need to find if nums dot length is equal to 1, return nums of 0. Right now, if nums of mid is greater than nums of mid plus 1, it's the pivot, right? We basically return mid. Else, you need to check the right side, right? Here, if less than, this is the pivot. Otherwise, you go to the left side, right? Now, int left is equal to nums of mid minus 1 and right is equal to nums of mid plus 1, right? If nums of mid is less than left and nums of mid is less than right, then that's the pivot, right? Otherwise, if nums of mid is greater than nums of 0, then you basically need to go to the left. I always go to the left side first, so I'll just remove this. So how in this scenario, when you will go to the left side? If nums of mid is less than nums of 0, right? Then you will go to the mid. High is equal to mid minus 1, else high is equal to low is equal to mid plus 1. So that is the case. So you basically return pivot, right? And into pivot is equal to find pivot and nums, turn nums of pivot. Yeah, yep, that is how it is. Mhm. Search in a rotated sorted array. Again, the same thing. You will find the pivot and then you will make a search on top of it. So I think these two are good problems. That's it for today, guys.